This is sort of, I'll say, is a bookend to air toxics in a way, in that air toxics cause birth defects, they cause cancer. Particulate matter, especially a certain type, does cause health effects. And what's unique with it is it's immediately evident. I mean, it's that kind of gagging phenomenon sometimes you get that you don't get with some other chemicals. So you can tell when the air has particulates in it, smoke. And that's what we want to look at briefly here. So I appreciate your patience, and then we'll break into groups. So particulate matter, there's different categories of the particulate matter. What we're most concerned about are the particulates that get deep into your lungs, into the alveoli, right where that oxygen interface occurs. So you're not too concerned about gravel on the driveway, right? They're not inhalable. So you have this inhalable, thoracic and respirable categories of things. You know, they get into different depths of your lungs, and we'll look at that in just a moment. So the smaller the particulate, the deeper it can get into your lungs. And so particulates can be solid or liquid. And not only do the particulates get deep into your lungs, but materials can be adsorbed, can stick to the surface of these particulates, and in that way the particulates are delivery vehicles for other chemicals like vanadium and things like that. So particulates are troublesome, and they're especially troublesome for those with respiratory illness like asthma, elderly children, and those sorts of populations. But there's a lot of discussion about their effects right now. But it's one of the things, like I say, is you can actually tell the effect very quickly. It's very evident. And it's kind of what you might normally call air pollution, because you can sense that directly. So it's worth a few moments. And this is what I talked about before, this sort of pathway. You have this respiratory epithelium in your respiratory system, which is this protective membrane and the moisture about the respiratory system that acts as this barrier to the intake of particulates. So you have pathogens, things that are pathogenic, that are hurtful, like allergens, kind of similar category. Those are things that produce allergies. So your body has this protective system in that way. So when you breathe in, particulates don't get in, they stick. But unfortunately, there are particulates, the small ones, and these are 10 microns or less, certainly 2.5 microns and less. So we're talking about times 10 to the minus 6 meters that get deep into your lungs and do get into the alveoli, these kind of, which is, I know it's kind of a bad diagram, but that's deep into your lungs. So the particulate matter, the PM 2.5s especially, are what people watch because of the depth that they penetrate. So, and this is just a physical sizing. So it's a human hair. This is from the EPA, and compared to beach sand and these kind of things. So in other words, it's one of the issues with air pollution control when people talk about, well, like, you know, this device captures this many kilograms per BTU or tons per BTU captured. Well, the problem isn't the particulates you capture in a filtering system, it's the size. It's the small particulates that are the most problematic. The big particulates drop out and are not so problematic in terms of health. So in other words, again, if you think about, like when we talk about rheological properties, you know, this kind of geeky stuff, if somebody talks about particulate emission, the very first question you want to ask is, what is the size distribution of the particulates? If they're all real big, 70 microns, not a big deal. If they're, well, I should say, but not that big a deal. Compared to the little guys, the 2.5, they go all the way down deep into your lungs, into these alveoli, and cause havoc there. So that's what we're talking about. This is showing the adsorption of different compounds onto particulates. So you get the stickiness that we've talked a lot about, even back with fluid dynamics and thermodynamics, phase change, and so it's a real effect. Now these are particulate matter, and we're actually going to break this down a little bit. So here you have the particulate matter distribution around the world. And what you'll see, like you look at the Sahara is high. So we have to look at this. You can see like India has surpassed China now for these PM 2.5 particulates. But this is good. I'm not going to read all this to you, but what is interesting is you do look at the source of these things. So sand is a particulate, okay? And it blows around and it's natural. And so is volcanic ash and these sort of things. So if you look at, let's see, Here they're trying, let's see, domestic fuel burning, natural sources, including soil dust and sea salt. That's the gray. So if you look at the Middle East, half of this is PM 2.5, by the way. This is a real fine particulates. Obviously, you get larger particulates. Half of it comes from sand. Now, this is talking about where it comes from, not the total quantity. Okay, so just to be aware of that. So the Middle East has less 2.5 micron particulates than does China and India, but the source of it, half of it's coming from the sand itself. So just an interesting, I think it's an interesting diagram because so it's kind of like three parts of the puzzle. If something's generating particulates, what's the size distribution? And that's what you're looking at. What are the small ones, these under 10 or 2.5 microns? And then you can say, well, then you can say, well, okay, what's being produced? And then you can say, what is producing them? Is it something I can control, or is it something I can't control? All right. And this has a little bit of an effect. Yeah, okay, well, I'm not going to look at the nitrogen cycle. So we'll stop here. But this does have a little bit of effect on indoor air quality. We talk about, because mold produces, we talk about viruses now a lot. Viruses are small particulates also. Mold produces particulates as well as these microbial volatile organic compounds, MVOCs, little like aromatic compounds that float around. So there's a lot to this. It's going to be, I guess, in the news. So particulates are just a funny thing. What we'll do is we'll end it here and just see if there's questions, but we'll continue on next time into combustion chemistry, which is really interesting. So when you really try to understand sustainability in this course, because it's kind of like a techie course, we're looking at what really is going on. And you can look at the PowerPoint. It's up on Plato. In fact, I have a lot of PowerPoints on Plato now. I put them, I don't ever cover all those, but I put a lot of them up there just so you can look at it. Because it is really interesting, because there's a lot of waving hands and all kinds of stuff going on. But if you kind of rest, like these two things, air toxics and fine particulates, those are two things you can really kind of say that's an issue. Air toxics, if you trust the EPA, you say, well, they cause cancer, birth defects, big deal. Fine particulates, they're a problem because they're gagging. Okay, it causes haze. You can tell immediately if there's an issue there. It's like smoking without a cigarette.